Well, once again, good evening, my dear. Let's go to the next topic, that is Cassegrain refracting telescope. Cassegrain. My dear, Cassegrain is more important than the Newtonian because Cassegrain is as I told you in my previous topic, it is the largest telescope, refracting telescope in India, my dear. And this has some conceptual also. We are here in the diagram. You can see I have used the two paraboloidal mirror. The two paraboloidal mirror. One is a primary. Here it is called primary mirror. This is the primary mirror, my dear. A concave mirror is a primary mirror, and the another is the convex mirror, that is a secondary mirror. So two paraboloidal mirror. There is no plane mirror concept. Take care. So small minute thing can be distinguished between a Newtonian and a Cassegrain. So now, my dear, let's start and beginning with the topic. You can say that with the first point, it consists of large concave mirror, concave paraboloidal mirror, now if I said large, it immediately you should think about large means what? Large focal length and large aperture. So it consists of large concave paraboloidal mirror, that is large focal length and large aperture, meaning of that, called primary mirror, having small hole. You can see there is a small hole, my dear. In the large concave mirror, there is a small hole, my dear, is provided, having small hole at its center. This hole is at the center of the large paraboloidal mirror. You can see in the diagram. Second, my dear, there is a small convex mirror called secondary mirror, my dear. There is a small convex mirror, you can see it is a secondary mirror because this is a primary, this is acting as a secondary mirror. And where I place this convex mirror? This convex mirror is placed near the focus of concave mirror. Near the focus of concave mirror, my dear. I have placed this convex mirror near the focus. You can see this mirror is placed near the focus of concave mirror. So this is a small convex mirror placed near the focus F of concave mirror, that is primary mirror. So I can say it is placed near the focus of concave mirror or near the focus of primary mirror, my dear. Nothing problem. And this is all about this, my dear. And apart from this, you can see there is a eyepiece. There is a eyepiece, my dear. The eyepiece is kept. The eyepiece is kept at the axis of telescope. It is placed at the axis of telescope, my dear. The eyepiece is placed at the axis of telescope, my dear, and close to hole of primary mirror. So 2 point is take care of this, that the eyepiece is kept at the axis of the telescope. This is at the axis of the telescope, my dear, and close to the, you can see the eyepiece is close to the hole of the primary mirror, my dear. So this is all about your construction, my dear. So, my dear, I have given, this is the way this instrument is constructed, the Cassegrain telescope. So please take care. There are three very important points which are supposed to say. There is a large concave mirror, nothing but a concave paraboloidal mirror, that is not a primary mirror, my dear, having a large aperture. There is a small hole at its center, that point. Second point is that, sir, there is a convex mirror which is a secondary mirror which is placed close to the, the convex mirror is placed close to the focus of the primary mirror, that is close to the focus of the concave mirror. You can see the diagram. And the third point which is important about eyepiece, this eyepiece is kept on the axis. It is kept on the axis of the telescope, my dear. You can see it is kept on the axis of the telescope. Earlier, my dear, the eyepiece was in Newtonian, the eyepiece was kept perpendicular to the axis of the telescope. Here it is kept on the axis of telescope, my dear, as I have mentioned also, on the axis of telescope, and close to the hole of the primary mirror. Close to the hole of the primary mirror. You can write these three basic things. Now, my dear, let's start for working, how it works and how it forms the final image. So the working is, here I am writing working. This is an important question with the exam point of view. So here is a working. If they ask only write working, so write only working, no need of writing this construction. Okay, working is what, my dear? First point, you can see a parallel beam of light, a parallel beam of light from distant object, a parallel beam of light from distant, you should write, my dear, in your own words also, but understand the concept. A parallel beam of light from distant object fall or incident, you can say here, incident on primary mirror of large aperture, that you all know primary mirror is a concave mirror. So it incident on primary mirror or concave mirror of large aperture, my dear, and before these rays, and before, you can see these rays are converging, that previous topic, they are also converging, but there was a plane mirror who intercepted the rays. Here there is a convex mirror who intercept the rays, my dear. So before these rays are converged to the focus F, you can write that point. Before these rays are converged to the focus F, before these rays are converged to focus F, as shown in figure, my dear, before these rays are converged to focus F, as shown in figure, they are reflected. They are reflected by convex mirror, my dear. You can see the diagram carefully. These rays, before that converge to this point, they get reflected. They are reflected. Look at the blue colored ring I have drawn. They are reflected by convex mirror and forms. They are reflected by convex mirror, formed real image, or you can say formed image. That image is called final image, formed final image I. Here I have mentioned I. So they are reflected by convex mirror, formed final image I, my dear, just outside the hole, of primary mirror. No need, if you wish, you just write just outside the hole, as shown in figure. So this is very crucial point, my dear. A parallel beam of light is coming from the distant object falling on the large mirror, that is a primary mirror, concave mirror. Before these rays are converged to this point F, they will be reflected by the convex mirror, which form the final image I just outside the hole. They are reflected by convex mirror and which form the final image I, convex mirror, which form the final image which formed final image I just outside the hole as shown in the figure, my dear. Am I clear, my dear? So I hope you are understanding. This is an important concept, that how it works. And my dear, at the end you can see there is an eyepiece. So as soon as the final image I is formed, this final image will be viewed through the eyepiece, right? So last line I can write, this final image I is viewed through the eyepiece kept near the hole of primary mirror. I hope the topic is clear to everybody. Now I will tell you what is the nature of the image, my dear. That is also an important concept. So let me tell you, it's a simple one. So a parallel beam of light from a distant object falling on primary mirror. From there, sir, it will be refracted, and before it get from the concave mirror, it will reflect. You can see these black colors, arrows. Am I clear? And sir, before it get converged to the focus F, there is a convex mirror. So before it get converged to focus F, there is a convex mirror which reflect these rays. Am I clear? And form the final image I just outside the hole. So before these rays are converged to focus F, they are reflected by the convex mirror, formed final image I just outside the hole as shown in the figure. This final image I, my dear, weave through an eyepiece. We will weave through the eyepiece. There is an eyepiece which will weaving this final image, and whenever you draw this diagram, take care, this eye should be little just outside the hole you should draw. Should not over here. It is just outside the hole which is weaved through the eyepiece, my dear, and this eyepiece is kept near the hole of the primary mirror. Now let us discuss about the nature of the error, my dear, image here. What is the nature of the image? Now my dear, quite important. First there are two images formed. The image is formed at F. Now the image is formed at F is by the you can see by the concave mirror. The image is formed by the at the F is by concave mirror, and it is on the same side of the object, you can say, because distant object is that it is on the same side. The first image is formed on the same side. It is real inverted. It is real inverted image, my dear. Am I clear? But this image I which is formed, my dear, is on the other side of the object, you can see. So it is a virtual image, my dear. This image is the virtual image with respect to the first image. But this image is a real inverted image with respect to the distant object. Because with respect to distant object, this is your real inverted image. On the same side of the mirror, my dear, the distant object, and on the same side of the mirror object, the image is obtaining. But this image I is virtual with respect to this image. I repeat, this final image I is virtual with respect to the first image F, formed at F. But it is real inverted with respect to the distant object or real object. So please take care of this line, which is very important. So this can be written over here. Look at it, I am writing this point. So my point about the nature of the image over here. So now let us discuss, my dear, the nature of the images. As I said, there are two images. The first image obtained at F, and the second image, the final image, is obtained at I. Okay. So now let's start by, my dear, the nature of image. The first image obtained at F, the first image obtained at F is real inverted. You can see here is a distant object. On the same side I am getting the image, my dear. So it is real inverted because it is a mirror. In the mirror, my dear, when the image is real inverted, this is a mirror. When the image is real inverted, when we get the image on the same side of the object, and when it is virtual erect, when we get the image on the other side of the object. So here, my dear, the first image obtained at F is real inverted with respect to the distant object. I hope it is clear. However, the final image I is virtual erect with respect to WRT. However, the final image I is virtual erect, my dear. This image is virtual erect, so it is on the other side of the object. You can see, because now this will be act as the object for this image. So however, this final image I is virtual erect with respect to the first image formed at F, but it is real inverted with respect to the distant object. So take care, my dear, this is very crucial line I have written here, nature of the image. The first image which is obtained at F is a real inverted. And you can imagine that this is a mirror on the, if the image is real inverted at F, it means the image form on the same side of the object. But my dear, the final image I, which is formed here, you can see just near the hole of the paraboloidal concave mirror, this real image I, Chaubesar, is virtual erect with respect to this. This is virtual erect with respect to the first image. I have written here, the final image I is virtual erect with respect to first image formed at F. But it is real inverted. This image is the real inverted with respect to the distant object. So this is all about, my dear, the Cassegrain refracting telescope, that the final image which is obtained is real inverted with respect to the distant object. Am I clear? Whereas in Newtonian telescope, it was a virtual erect and magnified image. But here the final image is a real inverted with respect to the distant object. So this is all about, my dear, Cassegrain refracting telescope. Now let's go to the advantages of refracting telescope over a refracting telescope.